So this is the unmanned aerial vehicle multi-rotor build video. So with this kit, you can build one of 5 different chassis in 2 different orientations. So we have a stretch X and a regular X. This comes in 3 different sizes and then 2 different sizes. So we've got our normal product safety information. Don't put it in your mouth. Don't burn the batteries, that kind of stuff. MINDS-i warranty, terms and conditions. We do a 120-day warranty for any defects in materials and workmanship, shipping errors, defective products, things like that. It is all patented. So it starts off, you've got a table of contents, goes through the airframe build, flight controller programming, pre-flight setup testing, pre-flight checklists, troubleshooting, and then the dashboard section. So we start off all of our instructions with the connector assembly and usage. This shows a 1-to-1 scale picture of all the different connectors we have and then how we assemble them. So the kit we'll be using now primarily will be panel locks, 2 locks, and 3 locks. This shows the core of the connector being assembled into it. It'll slide up to the center, so you want to make sure that the pin, little rib on the pin, lines up with the groove on the connector itself. So it'll show you, hey, you need to have the core pulled out to press it into the beams, not in, it won't go in. And then when it's in there all the way, you can press the core in, and it'll lock. And then you can cam it over, and that will prevent it from vibrating loose. And then to remove it, you'll click the tool in, turn it the other direction, and then pull the whole connector out on the tool itself. We get into the UAV airframe build. So this is where we'll actually build the main parts of the chassis itself. We have a part identification sheet. So the wiring itself can come in 3 different configurations color-wise. It's all ground power signal, whether it's black, red, white, black, red, yellow, or brown, red, yellow. It's still ground power signal. We've got our wiring guide for our reference for the whole kit. There are 4 motors and speed controllers. They go into the flight controller signal-wise, and then the power module power. Battery through the power module to the motors. This also powers the flight controller, the radio, and the GPS. The telemetry radio and the GPS are an optional thing. If you get the full lab, they'll be included, but if you get the competition kit, they won't be included. It covers our radio wiring and everything like that. This is all just for reference. It's also referred to later in the instructions. And this is where we get into the build section. So the first thing we have is we're going to build our motor, we call motor pods. So we'll have 1 clockwise and 1 counterclockwise orange, and 1 clockwise and 1 counterclockwise green. We pick our frame style. So we have our X and our stretch X. So we can build this in a 15 length, a 10 length, and a 6 length, or a 15 and a 10 for the stretch. This longer arm will have the softest flight characteristics. This will have a slightly more responsive and then the most responsive. And since these are equal length on all arms, it'll behave the same left, right as it does forwards, backwards. The stretch X has the longer arms, but they're narrowed in the front and back. So it'll be more responsive left and right for steering, but less responsive or smoother going forwards, backwards. This orientation will be better for like racing, whereas this will be better for general flight. We'll start the build process. There will be notes in here, so make sure you check to make sure that anything in red is an important factor. We're going to label these kind of things. So the build is pretty quick. Again, these are for use with the full lab, not the competition kit. Talk about using Velcro. It shows you the places to put the Velcro, loop side. The hook side goes on the actual parts that you're attaching down. So again, read the 2 sentences, make sure that you're paying attention to what it's telling you to. Things like this, where the signal wires on the inside, the ground is on the outside. It shows you a picture as well as telling you that at the same time. Continuing the build process. So like this is notes for the competition kit. So if you don't have that, you need the jumper in here to use the internal compass versus the external compass. Cleaning up the wiring, making sure that nothing's in the propellers or loose, hanging, things like that. And then we get into the programming. So the first section here we'll cover is the build section. So I'm going to start opening up the bags and we'll start the build process of the motor pods. So we're going to grab our bag with our motors and our propellers and the hardware. And then we're going to grab our bag with the motor mounts and then the beams. And then be careful when you're cutting open the bags. You don't want to cut any of the wiring and things like that. And then I leave anything that's not being used in the current step in the bags. That way I don't knock it off the table or things like that. So we'll start with one motor pod, and then we're going to find one of the clockwise motors in ESCs. So these are labeled on the ESC itself, counterclockwise, counterclockwise, and then clockwise. So we need one clockwise one safety duct, one motor mount, the screws, and the washers. So we got our safety duct, our motor pod, our motor and speed controller, and our hardware. So we're gonna set the nut down to the side, little bin, something like that, make sure you don't lose it. So with this, we want to snake the cables through here, pull the whole assembly through, and then we're going to take this assembly and we're going to fish it through there. And the idea is then we'll take one of these screws, we're going to line up through the safety duct, the motor pod, and into the motor. It's usually easier if you take the tool, put the screw on the end of the tool. You can look down in there and get a shot into that, and line it up. And once you get one in place, don't tighten it down all the way because that'll prevent you from moving it around to line up the next one. And then we will take the next one, line it up. And then once you have two of them in there, it won't wiggle, and then the next two will be much easier to assemble. And then once you have them in there, then you can go and tighten the rest of the screws down. So that is our clockwise orange motor pod. So we'll set that to the side. We'll grab another orange safety duct, motor mount, and this time a counterclockwise motor. And we'll do the same thing. We'll feed the wiring through. And we'll line up the holes. And then as you can, once you have all of them in, then you can tighten them all down. You don't really need to reef these super tight. They just need to be tightened down where you know they won't back out. And that's our counterclockwise one. And then now we're going to move on. We're going to do our green clockwise one. So clockwise motor, green duct, motor pod. And we'll fish our wires through. And we're going to attach the motor on. And then the last one. And then the next step is to pick our frame size. So we're going to pick the regular, what we call our X plate, and we're going to do with the 10 length beam arms. So we have our bag here with our plates and our long arms. So I'm going to open up this bag and grab the regular X plates. So with these plates, we have our top and our bottom plate, and so the top plate matches here, so the holes for attaching the beams arms, and then the bottom plate has these slots, and that'll be for later for running the strap through to hold our battery on. So then it's going to show us whatever length arms we're wanting to use, we're going to attach to the top plate and the motor pod itself. And then we have our top-down view here, and this is going to show our motors orientation-wise, so counterclockwise, clockwise, counterclockwise, clockwise. They're balanced pairs, so they're opposing each other, and that will prevent drift or yaw. So I'm going to grab my arms here. So I'm going to use the 10 length beams. And we're going to grab 2 for each arm for 8 total. So then I can start with whatever motor I want, just make sure that you match the counterclockwise to the counterclockwise. So in this case, I will take these two and I'm going to hold them in place while I put one of the connectors in, push the cord. So you can slide the core out. If you grab the core with your fingers, you can hold the core while you push the body into the connector itself, and then press the core in. And then once it's connected in, you can take your tool and you can cam it over and lock it in place. So we'll put all 4 connectors in on this end. And that's one of the motors, and then we're going to peel off the protective film. And we leave this on so that while it's being shipped to you, it doesn't scratch the film up a bunch. And then we'll do the same thing here. We'll take the plate, line up the connector, push it through. So then we'll do that 4 times and make sure that since this is the counterclockwise one, I'll lay it down here. And then I will work on the clockwise one next. to counterclockwise. And you can attach these to the frame or to the motor first, doesn't make any difference. Alright, so now that ones have them all attached, we'll move on to the next section. So with this, we're gonna grab our accessory bag, and what we're gonna put on is the landing gear itself. So this bag will have our threaded adapters, the rubber caps, the landing gear, and the washers, and then this bag will have the screws. So as before, I'm only gonna open up the section that has the screws itself. That way I don't lose the other parts. And with most of the kits, you'll find that we only need 4 screws, but we put 5 of them in there just in case you do lose one. That way it's much easier to continue the build process instead of having to try to find the one screw that you dropped. Same thing with like these threaded adapters. You'll need 4 of them, but there's 5 of them in the bag. And for the bags like this, instead of cutting this way and trying to squeeze the parts out of there, if you cut along with where they're sealed, the parts will just roll out of the bag, and it's much easier to get them out of the bag at that point. And then since we don't need all of these washers, I am just going to pour out the 4 that I need. So we're gonna go in the hole closest to the frame, and it doesn't matter which one you do. In this case, it's this hole here on either one of these, and you can do them radially or mirrored, doesn't matter. We're gonna take the darker one with the larger hole and put it in the top. And then there's a little teeth that you can line up, and once you line up, it'll press in. Then we'll take the smaller one and put it in the bottom. And then if you hold that a little bit in the bottom with your finger, we can actually take a washer and screw, and we'll drop it in the top. And then we'll take our 3/32 tool, and we're gonna tighten this down. And it'll take a little bit of force the first bit, but what happens is you'll actually start cutting threads into this bottom connector, and that once it tightens up, will hold itself in place, kind of like a nylon locking nut. And then once it's tightened down, we can take our landing gear and thread that onto the bottom, and then place one of the rubber feet on the end of that. And then we'll do the same thing for all 4 corners. Start with one of the darker threaded adapters that goes on the top. The lighter one goes on the bottom. I'll take a washer and screw. And then when we're done, it should look like that. And I'll set my extra parts aside. So we should have all 4 of the landing gear on there and all 4 motors. And then now we're going to get our power module out, and then we're going to connect the power module to each of the motors. So we'll get our power module. So the power module has our battery plug, which is an XT60. We have a 6-pin cable. This will plug into our microcontroller. And then on this end, we have 4 red and 4 black wires. These will plug into our 4 different speed controllers in a matching pair. So as this shows, we want to make sure that we plug black to black and red to red. That way we don't have a short circuit or a reverse polarity problem. So we'll lay this down. And this is where you can kind of line up these motors in here. What I like to do at this point is, you don't have to do it at this step, you can do it later and clean it up afterwards. Is I will actually take 4 of the supplied zip ties, and I will kind of loop the wire around, and I'm going to attach each of these speed controllers to the arms. And for me, this helps me keep all the wiring cleaner, keeps everything in a place so that when you work on it, you can not have to worry about catching the wires on anything. So what I will do is I will make sure that I have the label, the clockwise or counterclockwise, sticking up so that I can see it later and make sure that, yes, I have correctly assembled these. So we'll do that for all 4 of these. So loop it around, and we want to make sure that they're all in a similar place. They all have enough wire to reach towards the center. Okay. So we're going to take this, and I like to grab a pair, a black and a red. And then I will just start on one corner, black to black, red to red. Grab the next pair, and then just move my way around, making sure I double check the polarity each time. All right, and then I can pull this all down. And then the next step, we're going to grab our extension wires, and then we're going to connect them to the outputs of the speed controllers. And we're going to make sure that we have black to black and white to white in this case. So these have two different sides. You have a male side and a female side. In this case, we want the female side. And then we're going to take that and line it up with the male side off the speed controller. And then we want to make sure that we have black to black and white to white. And we'll do that in all four corners. And this will likely be one of the points where you make the first mistake. Is you'll have one of these that we flipped around, and then later on when we do the programming, you'll notice that one of the motors doesn't want to spin. So now we're going to label the four extension wires. That way when we put the bottom plate on, we know which ones go to which corner without having to undo it and trace the wires back. So this is the bottom view. So this corner will be labeled number 1. So you can either label directly on the extension itself, or I'm going to take a little piece of masking tape. And I will cut a little strip and put one on each of these and then label them all. So we'll start with number 1, which will be this front corner. And then this will be 3. And this back corner will be 2. So again, just put a warning in here, make sure you double check that you have them labeled with the 1, 2, 3, and 4. And then now we're going to tuck all of the wiring on the inside. And what I like to do is prep this next step here. So this will be our bottom plate, and then our Velcro strap for our battery. There'll be a little, they call a plug in here that you want to pull out. That way you can feed the strap through itself. So we have our bottom plate. We'll peel off the protective film. And then we'll feed this strap through. And then we'll have this ready to cover all the electronics. So for this section, kind of just align everything so that it's pointed down through the back. The green is the front. And this will be the most fiddly bit, and it doesn't have to be perfect. You just want to make sure that the majority of your wiring is out of harm's way, so it can't be sucked up into a propeller. So take the speed controller wires and we'll put the power module right in the middle, and then we're going to take this bundle of wire and we'll just kind of tuck it in here. And we're going to make sure that we have none of the wires overlapping the holes that we need to plug in connectors to have the bottom plate take our bottom plate, I'm going to slide it over. So now that we've got the bottom plate with electronics in, we're going to put all of our connectors into these holes and secure this bottom plate. I like to put one in on each corner first and then go back and do the other four. And then with this step, you want to make sure that you're not pinching any wires in between the two plates. That way you're not going to cause any problems for you later down the road. All right, then we're going to work on building our GPS tower and our telemetry tower. This is one, again, where the note says if you're using the competition kit, you don't need to build these. So we're going to grab our pieces here, 10, 7, 2 3-beams, 4 transitions, and then 2 3-locks and 2 2-locks. So grab our 3 locks. So again, you want to make sure that you're paying attention to the orientation and direction of how the parts are assembled. So we're going to put the 3-lock through this transition, make sure it's matching the picture. And then this transition on the back side, we want to make sure that we have the holes all lining up and not having it upside down or inverted. And then we'll do the same thing with the 3s. Put our connector in and overlap them. So that matches, we can set it to the side. Did forget a step. And then we'll do the same thing here. Put it through this front connector. Make sure these 3 holes are lined up with each other. And put our 2-lock in. And then the next step, we're going to put these into the main frame. And this is where you want to make sure you have the orientation matched. So in this case, the green picture is shown towards me, and then this is going to go on my left side. So put that in place. And then secure it with 2 connectors. And then we'll put the other one on the other side. And then we'll move on. So then the bottom 2 connectors go in, and then these holes are on either side, so you may have to move your Velcro strap out of the way to get to them. All right, and then the next step, we're going to secure some Velcro pieces, and we always suggest putting the loop side or the hook side. Pick one to put on the vehicle, put one to put on the accessories. In this case, I'm putting the loop side on the vehicle. So we're going to cut up some 1-inch chunks. So there's a picture here that you can use as a reference for size for the pieces to cut them up. And then if you pinch the corner of the hook side, then you can peel it open. It makes it easy to get the film off the back of them. And then we're just going to make sure we have a piece of Velcro everywhere it shows on the instructions. All right, then we are going to move to getting our electronics out. And we're going to mount the flight controller, telemetry radio, and GPS. And then we want to make sure that we read the notes. There's an arrow on the GPS that needs to be pointing the same direction as the arrow on the flight controller. Front is green, so forwards towards the front, the arrows go towards the front. This is the step you will not put the GPS or telemetry if you have the competition kit. So again, making sure that we cut away from any of our cables or wires. We don't want to cut into them. So we'll have two different modules with the telemetry. We have one with the thumb drive end for the USB port that goes in your computer. That will go with either the large antenna or a standard antenna, depending on which kit you receive. We can set those off to the side for now. We want to find the end with the 4-pin cable. We're going to thread on our antenna. And then we're going to find our cable that has a 4-pin end on one side and a 5-pin end on the other. And when we plug the cables in, we want to make sure that we're looking at the polarity of the cable. The pins are offset top to bottom, as well as on the back side of the plug has 2 little dimples that'll match with the 2 holes in the plug itself. So in this case, the dimples go down towards the board. We'll plug that in. And then we want to make sure that we have our hook side of our Velcro to match the loop side that we placed already. And then we also have our forwards arrow. It's labeled forwards, the arrow points forwards. We're going to attach this to the flight controller, and we're going to align that as straight as we can, forwards, backwards. And then same thing with the GPS module. It says GPS module, it's got an arrow pointing forwards. We're going to attach that to the GPS tower with the arrow pointing forwards. The telemetry radio just needs to be pointed up, doesn't have to be in any specific orientation. And then when we move on, we're going to connect our ESC motor wires to the flight controller. And so we're going to make sure that we have the polarity correct according to the pictures. In this case, we have the signal wires going in towards the numbering, and the ground wires on the outside of each case. And this is where before we had labeled these 1, 2, 3, and 4. We're going to put them into the pins 1, 2, 3, and 4 on the output side. So turn it around, and we have our output side, and then we're going to grab our 4 servo wires. And see, that's 2. We'll plug it into number 2. And this is 4. And then we have 3. And then lastly, number 1. And again, the most important part is to make sure that we have our wiring matching the pictures. Signal wires on the in towards the numbers, ground wires on the out towards the outside, just as it shows. And then for the next step, again, we're talking about optional GPS and telemetry. And then we're going to wire our receiver to our flight controller with our 5 male-to-male cables. The receiver is located in your remote control box. So we're going to open up our box here with our remote control and slide out the foam insert. If you lift up the remote control, underneath you'll have your receiver, a USB cable, and your bind plug. You want to make sure you don't lose your bind plug. We'll need that later. So the receiver has channel 1 through 6 listed on the side of it here, and just like we did with the flight controller, when we plug the cables in, we want the signal wire, in this case the orange wire, facing towards the numbering. And I like to put all of the plugs in on one of the devices, whether it's the receiver or the flight controller first, and then match them up 1 to 1, 2 to 2, 3 to 3, 4 to 4, and 5 to 5. So just as it says before, make sure all your wiring and polarity is correct. And then when we plug into the flight controller, we're using the signal wire in towards the numbers as well. So then we'll take number 1, and we're going to plug this into port 1 on the input side. And then number 2 into port 2. And then 3 to 3, 4 to 4, and then 5 to 5. And then before we secure this down, I'll again just double check to make sure that all of the wires are facing the same direction. 1 to 1, 2 to 2, 3 to 3, 4 to 4, and 5 to 5. And then to secure this, I like to just kind of give it a flip around, tucks the wires nicely, and then secure it down with the Velcro. So it should look something like that. And then now we can move on, and we're going to plug in our power module. So this will be on the back, came out with the servo wires. It has a 6-pin plug with a red wire on one end, and then it should be 5 black wires. Now in this case, we want to make sure we again follow the polarity of the images. The red wire goes inside towards the numbering, and the black wire is on the outside. So this will plug into the port labeled PM for power module. And then we can move on, and we're going to plug in our telemetry radio and our GPS. The telemetry radio will have a 5-pin plug, and we're going to make sure we have our red wire and our ground wire. And then as it shows, the red wire goes in towards the numbers in the port that says telem for telemetry. This is a little bit difficult to snake in there, but it will clip in just like the power module one. And then for our GPS, we're going to plug in our top wires and our bottom wires. It has a 5-pin plug, and there is a red wire and a black wire. And as everything before, the red wire goes in towards the numbers, black wire outside towards the edge of the case. I like to wrap this around the antenna post for the GPS. Keeps the wiring tight and out of the safety ducts. So this has offset pins like before. We want to make sure that we have the polarity correct. There's little dimples on the back of the side of the connector. The dimples on the connector in this case go down. So we will plug this one into the port above where it says GPS. And then the smaller connector, same thing. There's offset pins and dimples on it. And the dimples in this case, again, will go down towards the bottom edge of the case. So with that plugged in, again, everything's labeled. Ports show up as before, ground wire on the outside, red wire on the inside. So this page is for if you're using the competition kit, so you're not going to use the GPS or telemetry. You can use a jumper to use the internal compass versus the external compass. And it shows pictures without the jumper, but plugging in the GPS versus with the jumper and no GPS. And this kind of tells you how to keep all the wiring cleaned up and tight. Shows you where to attach the antennas, things like that, just to make sure you don't want anything to get into the propellers. So we're going to secure our antennas to the front of the arms for the green ducts. Again, you can mount them pretty much anywhere as long as they're 90 degrees apart. So we're going to mount them to these front arms. That's a convenient place to keep them out of the way. can also take some of the other wires that are loose, if you have any extra zip ties, and you can create a little bundle. Just to clean this up a little bit. And you don't need to pull these zip ties on the wiring super tight, just tight enough to hold everything in place. So we've got everything kind of cleaned up and out of the way. The next step to get into the programming. So for the programming, we're going to do our calibrate sensors, calibrate our ESCs, and then we're going to load the quadcopter flight program. So you have to do all of these steps in this order, otherwise it won't work. Calibrating the sensors, calibrates the accelerometer and compass. Calibrating the ESC sets the high throttle and low throttle for all 4 ESCs at the same time. And then the quadcopter flight code is the actual code that's on there that allows us to fly it. We gotta use the USB cable to plug it into the computer. There's a link for downloading Arduino if it's not already installed. For the calibrate sensors code, there's a video that we can go along with as well. The Arduino program, we're going to open the calibrate sensors code and go to libraries, MINDS-i drone, calibrate sensors. It's an up arrow for opening the libraries. It shows pictures of all the steps to go through, double checking your board and your port, uploading the code, waiting until it's done. In this case, we're going to open our serial monitor. It's going to print out a message for us. It's going to ask us if we'd like to tune the sensors. We're going to type in a Y and hit enter. And then it's going to stream out our data. It's going to stream out a negative X, a positive X, negative Y, negative Z, positive Z. So if you start with the vehicle flat on the ground, positive Z will be the first number to go OK. And then we can go to negative Z, will be upside down. And then we have positive X on the right, negative X on the left, negative X or negative Y on the front, and then positive Y on the back. And you'll hold it on all those faces, just like the pictures show, until it says OK in all of the 6 of the rows. And then once it's done, it's going to ask us if we'd like to save the information. Type in a Y and hit enter. And then we'll move on to the calibrating ESCs and then uploading the flight code.
All right, today we're going to go over Unit 4, Lesson 4.43. We're going to cover the gyro and accelerometer exercises. So first thing we want to do is we want to go through and we have to calibrate our sensors. So we'll click the little open button, scroll all the way down. It says libraries, or MINDS-i drone. We're going to go to where it says calibrate sensors. We'll open that up. So what this program will do, we'll actually open up with the serial monitor, and it will print out this message, and it'll tell you how to calibrate the sensors. We're going to go up to Tools. We're going to make sure that we have the correct board selected, the Arduino Genuino Mega or Mega 2560. Go back up to Tools, go to Port. Make sure we select the port that has the Genuino Mega or Mega 2560. And we'll hit the Upload button. We'll wait for the green bar to go across as it's uploading. Sometimes it takes a second or two. And then once it's done uploading, see us say done uploading over here. We're going to go up and we're going to click on the serial monitor in the upper right hand corner. And as we open the serial monitor, it'll print out, it says, hello, to calibrate your APM2, you will need to hold the device very steady on each axis. The progress indicator will show if the sensor is lined up with an axis. Just hold it on any axis long enough to get a good reading, and then move to the rest. So tune now, yes, skip straight to streaming sensor data now. So click up here in the top bar, type in a Y, hit enter, and it's going to spit out a whole series of X positive, X negative, Y positive, Z negative, Z positive. And so you can see where the Z just switched to OKs. That means it's got good enough readings sitting on the Z positive axis. So now we can tip it on its side and we'll get X negative. Wait till it says OK. Tip it on its other side. We'll get X positive to say OK. We'll go for the Fourth side, get the Y negative. Your fifth side, get the Y positive. And upside down, and then we'll get the Z negative. Now once it's done, you'll get the message saying the mag axis 0 is inverted, mag axis 1 is inverted. The raw shift scaling, the new accelerometer tuning values, shifting it X, Y, and Z by these values, scaling it by these values, new magnometer values. Important thing is we want, would you like to save these values, yes or no? So again, back up in here, hit the Y button, hit enter, and now what it does is it's going to stream out the raw values for your accelerometer and your magnometer. So what we're seeing here is X, Y, and Z. So Z should be 1.0, it's 1 G's worth of gravity force pulling us down. And you can tip, and as you tip, Z will go down, and in this case, Y goes up. Maybe tip the other way, Z will go down, and X will go up. Until you get to the side, and then one's back to 0, one's back to 1. So you always have a maximum of 1 and a minimum of 0 for 1 G force pulling you down. And that'll be it for the calibration section for this video.